Okay, so we're just going to have a quick look over significant figures. So very different. You can be asked either. You can be asked for significant figures, or you could be asked to a decimal place. So you need to be really careful and be reading the questions. So with significant figures, the rules for the are the following. So all non-zero digits are significant. So when we mean by non-zero, like 1, 2, 3, whatever. Okay, and then all zeros between significant numbers. So if you have a 0 in between your other digits, like a 2 or 3 or whatever, it's considered significant. And after the decimal point, all zeros to the right of a non-zero digits are significant. So what do we mean by that one is, so if you have a number, say it looks like this, okay, and if I said round to 3, if I said do 3 significant figures, it would look like this. Now we don't start counting until we get non-zero numbers, which is here. So that's where I would start, and I go 7, 4. Now this is the third one, but like normal rounding, you look to see what the fourth one is, and because the fourth one's higher than 5, it becomes 7, 4, 1. That's 3 significant figures. Okay, so that's what they're meaning there. So here they've done a little bit of an example with a number, and then they've said 2 significant figures, 1, and so on. And then down here we did another example with the 3. What I want you to be careful with, which is what you're gonna see, if I do another example, if you have like, and we'll see it probably more so in the next unit as well, when we have, say, a big number. So say we had a, like that. Okay, so if we start talking about money, we don't really want to go to the nearest dollar when we're talking about big numbers. So they will most likely say if I said 2 significant figures here. So if I say 2 significant figures, I start counting as soon as I get the non-zero numbers. So for this, it would be 1. Now, I look at the third one, it would be 8. Now, it doesn't make sense to just leave it like that, because down here, this is where our decimal point would be normally. So it doesn't make sense. So once you've done that, all the other spots have to be left in a 0. And can you see how it gets rounded to 180,000? And that's what the number is, isn't it? It's roughly 180,000. So be careful, that's explaining that.
Okay, so today we're going to look at bivariate data. So bivariate data is when we have generally 2 lists, or we're taking two variables. So we're getting 2 pieces of information from, say, the same source. So say, for example, if I was collecting all everyone's weight and height from the class, so you can see there we're going to have 2 lists of data, but each data source, so the individual will have it came from them. So there's other things, like often when we have we do surveys, they might ask whether the gender, whether you're male or female, and then ask maybe a question on whether you were for wearing masks or not wearing masks. So today we're going to look at so we obviously see that we have 2 variables, and we're going to first look at when we have 2 categorical variables. But when we have these 2 variables, or 2 pieces of information, we say that one is the response variable and one is the explanatory variable. So often in your sciences, you know the response variable as the dependent variable and the explanatory variable as the IV, the independent variable. And if we have, when we have a set of axes, you would have seen that we put the response variable on the y-axis and the explanatory variable on the x-axis. Okay, so the explanatory variable is what we say is independent, so it's not affected by the other one. So we've got an example here where they surveyed whether you're male or female and your attitude to gun control. So whether you're male or female, the sex, is independent. So that won't change or won't be influenced by the other variable. But where your attitude to gun control, that may change if you're male or female. So they're saying that generally would tend that females would be more for having gun control. Okay, so we often use the words predict. So if they're predicting anything, that will be the response variable. It's what you're investigating normally and looking at. So we'd be looking at their attitude to gun control. So that becomes the response variable. Okay, so one way of displaying bivariate data is a two-way frequency table. And this is definitely when we have two categorical variables. Sorry. So when we have two categorical variables, a two-way frequency table is quite good. So here we've got this example where they collected whether they were male or female, and we were saying that is the explanatory variable, and their attitude, and we're looking at their attitude, so their response to gun control. So here we've got the data that we've collected. Now we were going to, with this data, we to a percentage frequency table, because we want to be able to comment on that. Because at the moment we could say, all right, there were 30, we look at gun control, there were 32 males and 30 women for gun control. But if you look at their totals are different. So we're going to percentage this table. So we would percentage down like that. So what we're going to say is 32 out of the 58 males, and we times by 100, and we're going to get percentages, and we'll see that on the next page. So here we've done that. So here, this was the 32 out of the 58 males times 100 gave us the 55.2%. Okay, so now when we look at the data, we can see that if we look at for gun control, we can see there was 55% of males were for gun control and 71% of females were for gun control. Now, because there's a considerable difference, there's a difference there, they differ, or there's a change, we say. So if they differ and there's a change, we say that there is an association between the two variables. We might even say, or they might even say that they're related. So the two variables are related some way. So sometimes they use the word related, sometimes they use association. All right, so what we do, we've seen this data and we need to report on it. So here's an example of the report. So from the table, we see a high percentage of females were for gun control with males. So 71% females and 55.2% for males. This indicates that person's attitude to gun control is related to their sex. So generally with these questions, they're always worth 2 marks. And you are going to get 1 mark for the statement, for statement, and that's the statement of whether there is a relation. So the data does indicate there's an person's attitude is related to the sex, and then you're going to say and say how it differs, and it did say it was higher, females were higher, that's that statement, and then you're going to get 1 mark for using the stats. Okay, so you have to quote the stats, and here they're quoting those stats to show the difference. All right, so here's an example of when it doesn't differ. So they went into a cinema and they looked at attitude to having mobile phones turned on in the cinema. So once again, this would be, the sex would be the explanatory variable, and their attitude to having mobiles, and that would be the response. So having them banned in cinemas. So if you have a look here, they've already done the percentages. So we have they're very similar. So similar stats. So that equals no association or not related. No association or not related. So down here, when we look at the report, we see from the table, we see the percentage of males and females in support of banning mobile phones was similar, and they've done the stats. So there's their 1 mark. And this indicates that the person's support for banning mobile phones is not related. And there's the statement saying whether it was associated or not, and it's not related, and there's their other mark. Okay, so here we go on to an exam question. So at a police checkpoint on a freeway, vehicles were randomly selected for a vehicle and license check. The two-way frequency table below shows the license type, so whether they were P-plate or full driver, and whether they had a roadworthy or unroadworthy car. So the license type is the EV, and whether they have a roadworthy, they're looking to see whether their driver roadworthy or unroadworthy. That's a response. So here the first question was circle 2 of the following 4 words that can be used to describe the variable roadworthiness. So roadworthiness is definitely a categorical. And we have like roadworthy, unroadworthy. There's no order really into that, so that's a nominal order. Now, we're looking down here, it says, does the data support the opinion that licensed driver is associated with roadworthiness of the car? So if we look up here, if we just look at one category, roadworthy, 85% of P-platers drive a roadworthy car, and so do 87. So because this is similar, I'm going to say that it is not related. Okay, so it doesn't indicate, there's not associated. So down here, we've got an examiner's answer. The data does not support the opinion that the type of licensed driver is associated with roadworthiness of car. There's 1 mark, because this is worth 2. And for example, 85% of the P-platers drive a roadworthy car, and 87% of the full license drive a roadworthy car. So you just needed these 2 statements. You could use the other stat if you want, and that's the alternate example there. Okay, so in this exam question, the following two-way frequency table was formed from the data generated when the entire population of 62 mammals were similarly categorized. So their exposure to attack during sleep, and their likelihood of attack. So we're going to look at whether they're going to get attacked, so that's a response, and exposure to the sleep, we're going to say is attack is explanatory variable. So as we said, we've got the numbers here, and it's always good to make them into percentages, but we'll keep going on with the questions and I'll come back to that. So if I look at question 1, how many of these 62 mammals had both high likelihood of attack and high exposure of attack in sleep? So I'm looking at high likelihood of attack and high exposure, so we're just simply 15. Now, it says in the next question, it says, of those mammals with medium likelihood of attack, so just of the median, so just across there, what percentage of them had a low exposure? So just of the median, so if we add up the median total, there was 4 in total. So we had 2 out of the 4, and we're going to, because it's a percentage, so when we do percentages is always the amount out of the total times 100. So they often tell you what your total is in the beginning of the question, which is here, of those medium likely. So that all of those animals, that's what we want, and which ones were low. So we do this and we end up with 50%. Okay, so then to this final question, it says, does the information in the table support the contention that likelihood of attack is associated to exposure to attack during sleep? Justify quoting appropriate percentages. It's sufficient to consider just only one category of likelihood of attack. So we want to make our numbers percentages, because we know we might not have equals. So what we're going to do is we percentage, as I said over here, percentage down the columns. So this low exposure, there's a total of 34. So if I look at this one, 31 over 34 times 100 gives 91%. Okay, so then if we do that for the next one, in the medium exposure to attack, there's 9 of them. And if we just look at the low, there was 8 in low likelihood of attack. So 8 out of 9 becomes 100. And then if we have 2 out of 19, we get 11%. So what we're going to do then is we will comment across here, because that said it's okay to consider just one category. So we're just going to consider the low likelihood of attack. So we can see as exposure to attack increases, the likelihood of attack decreases. And so I'm just going to pop in the examiner's answer here. Okay, so we can see the percentage of animals with low likelihood of attack decreases with increased exposure to sleep. So we can see the increasing exposure with low 91, medium 89, and that. There's a couple of other alternative answers there which you could do, but we just needed to note that there's a change, and we said we quoted to the stats, so therefore we get the marks. Okay, in this, we can also, we've seen earlier in the year, we saw that our percentage frequency tables can be made into segmented bar charts. So we can quote the difference here too. So here is, what do we have? Attitude to gun control. And we can clearly see that this, the female light blue category is larger, so you'll be able to comment. Down here, they've got whether you're smoking status, so whether the type of whether you were a smoker or not, so that would be the response. And then they looked at your education level on how high you went through that. So if we look at the segmented bar chart, it's quickly easy to see down here on the bottom. If you just, I'm going to pick the smokers, you can see that as your education level increases, the percentage of smokers decreases. So from the table, we see that the percentage of smokers clearly decreases with education level, and they're going to quote those stats from 39 to thing. Because there's a few they quoted to, that should be okay. And this indicates that smoking is related to, because there is a change, we can say that it's related to education levels.